All right, you guys. So, as promised, as I've kind of talked about so far this week here, um, we've got one more day to review some writing linear equation stuff. So, I've kind of handpicked three problems that I want to discuss for you guys or with you guys this morning. I've got a couple more problems that I'm going to have you practicing. It'll also count as an assignment grade, just like Monday and Tuesdays. Assignments are going to count as assignment grades, even though they're review and they're meant to kind of just hopefully close the gap for anybody that's going to be retaking their quiz tomorrow. These are going to count as actual assignments, so make sure you're getting them done whether you plan on doing the retake or not, okay? So I did send out an email yesterday to everybody, whether you took the quiz yet or not. If you haven't yet taken the quiz, I sent out an email just basically letting you know that you'll be taking it or reminding you that you'll be taking the quiz tomorrow, either in class or if you are quarantined. I had mentioned that we're going to try and do a 10 a.m. Google Meet with everybody tomorrow who is working from home. I will, once I get everybody logged onto the Meet or get you individually logged onto the Meet, I will then send you the actual quiz either through Classroom or through email. You'll basically just sit there in front of your computer, take the quiz, just so I can kind of keep an eye on you, make sure that you're not using your notes or anything like that. And then you will just basically do the same thing that you always do before you leave the meeting or the Zoom call or whatever we end up doing. Basically, you'll snap a picture of all your work, send it to me, and that is how we're going to go about navigating this quiz. Okay? So, like I had mentioned though, this is just kind of a recap. You may notice that this first example that I give you is actually one of the homework problems from yesterday. And I know I had a handful of people that actually had emailed me throughout the day asking for some help on this one because of the decimal points. The decimal points threw us off just a little bit. So I figured this would be a good one to kind of get started with. It is kind of a typical thing. It is a typical problem in that it gives you two ordered pairs. So the obvious thing that we do first is we begin by calculating our slope, which is the difference in the y's. So you subtract the two y coordinates, 2.8 and 3.4. So here it is, 2.8 minus 3.4 on top. And then you do the same thing on the bottom for your x's, 2.2 minus 4.6. And then here's what you get. 2.8 minus 3.4 is negative 0.6. And then on the bottom, it's 2.2 minus 4.6 is negative 2.4. So there's two things I want to point out to everybody here. And this is kind of for those that asked for some clarification on this. This is what I basically told them. The obvious thing is that the negatives cancel. It's a negative over a negative, so those cancel. The weird part is both the top and the bottom of this fraction, this slope, have decimals in them. So literally, all you have to do is you have to kind of follow the principle that whatever you do to the top part of a fraction, you do to the same to the bottom and vice versa. So literally, all I'm going to do to these two decimals, 0.6 and 2.4, is I'm going to take both the top and bottom and I'm going to slide the decimal point 1 to the right. So when I slide 0.6 to the right, it becomes 0.6 point, or that's basically just 6, because if you move the decimal to the end, you just drop it. It's 6 now on top. And then the denominator, the bottom, when I do the same thing, 2.4 becomes 24. So 0.6 over 2.4 is exactly equivalent to just 6 over 24. It's a very simple tool, a very simple skill, but ultimately I'm just kind of remembering that slope needs to be a fraction. So I had to get the decimals out of there somehow, and that was the simplest way to do it. Then I can just divide. 6 and 24 are both divisible by 6. You get 1 and 4. So very simple skill there of turning a slope problem, something that has to stay as a fraction, turning it into a nice looking fraction by just simply moving decimal points. Okay, super simple skill. Now from here, this is the part that I've really for you guys been trying to emphasize. Okay, when you go into this quiz, this is the main thing you need to be able to do consistently. You need to be able to take the slope and take either point. I'm going to pick this one right here, the second one, and you need to plug those into point slope form. Okay, so point slope form always looks like this: the letter y followed by the opposite of the y coordinate. So the opposite of 2.8 is negative 2.8. Okay, so let me just check my camera here, make sure you guys can still see this all good. All right, then comes our equal sign and our slope. So equals 1/4, and then in parentheses, the letter x, the variable x, followed by the opposite of the x coordinate. So the opposite of 2.2 is negative 2.2. Now, this is where it gets just a little bit murky, okay? This is a problem that started with decimal points. So I've kind of been preaching to you guys all year so far about the importance of remembering you can only have decimal points in your answer if there were decimal points in the problem. So you can have decimals in your answer here, but not for the slope. Slope can never be a decimal point. Slope has to be a fraction or an integer, okay? So it's going to be a little bit weird, but basically all I got to do here is distribute 1/4. So 1/4 times x is 1/4 x. And then 1/4 times negative 2.2 is obviously going to be a negative. But here's the thing, you guys. If we want to do 1/4 times 2.2, since decimals are okay here, we can go to our calculator and we can take 2.2, and the equivalent of multiplying by 1/4 is just dividing by 4. It's just like a half. The equivalent of multiplying by a half is just dividing by 2. So it's the same thing here. All I'm going to do on my calculator is 2.2 divided by 4. I get 0.55. And again, it's okay on this problem to have decimals here because my problem had decimals to start with. The last step, as always, and we're going to do this a couple more times here as we go down and look at these next two examples, is to add or subtract to get y by itself. So here's your slope-intercept equation for the line that passes through those points. Y equals 1/4 x comes down, negative 0.55 plus 2.8 is positive 2.25. And we've kind of said this all along, your y-intercept is okay to be a decimal. It's okay to be a mixed number. It's okay to be a fraction because it's your y-intercept, not your slope. Okay, so that was just, like I said, that was a question that came up yesterday from a couple people, and I really actually liked that one. So I figured it was a good conversation to have with everybody as we went through the stuff today. All right. Now we're going to get into parallel and perpendicular, and I'm going to try and, even though we're communicating remotely here, I'm going to try and really explain to you guys where this comes from so that hopefully everybody will really embrace just how simple these problems actually are. Okay, so in this example, we're supposed to write the equation of a line that is parallel to this one, y equals 1/2 x minus 5. And it's got to be parallel to that, and it's got to pass through this point 2, 3. So if we go back to junior high type math here, okay, junior high type math is when we first started learning how to graph slope-intercept equations. So at this point of the game, everybody should be able to do this. Everybody should be able to graph this equation. And remember, we're putting the problem on hold for a second, okay? You're not actually graphing. That's not the point of this problem. But I want to see that if I can convey to you guys how this actually, or what we're actually doing, I'm hoping that the actual work will make more sense to everybody, okay? So if I go to graph this, I put a dot at -5 for my y-intercept. So there's -5 for this line's y-intercept. It's got a slope of 1/2, so it's got a rise of 1 and a run of 2. So if I go from this point, if I rise 1 and run 2, and I put a dot there, what I can do is I can draw that line. Okay, so there is that line. That's not my line. That's the line my line needs to be parallel to. So think about this. The line that we're going to find in just a second has to be parallel to this one, but it's going to be above it because it has to pass through the point 2, 3. So the point 2, 3, that's over 2, up 3, that's this point right here. And then right here, I'm hoping to kind of make sure that this makes sense now. How am I going to draw a line that goes through this point right here, 2, 3, and is parallel to this one? Well, we could kind of just eyeball it here and draw it in. But what I really want everybody to understand is what's going to make them parallel is just like I had to go up 1 over 2 for this one, rise 1, run 2. If this one's going to be parallel, it's got to have the same thing. It's got to have a rise of 1 and a run of 2. If I draw in this line now, you can see, yeah, they're parallel to one another. Y equals 1/2 x minus 5 is down here. My line is up here. But what made them parallel is they both had a rise of 1 and a run of 2. A rise of 1 and a run of 2. So the point I'm trying to make to you guys here is this. Up here, we had to do this work right here. We had to do all of this work just to get our slope as 1/4. Down here, you don't have to do any of that work. We know what our slope needs to be for our line. If my line down here that I'm going to write the equation to has to be parallel to this one, then they have to have the same slope. Parallel lines have identical slope. So you don't have to do all of this work. As soon as they tell us, as soon as the problem tells us that our line has to be parallel to this line, our line has to have a slope that's the same as that one. So it's got to have a slope of 1/2. If you stop and think now from what I've been really harping on the last 2 days now, and then going back when we were going through this the initial time, all it takes to get these problems started is the slope and a point that it passes through. Because if you have that, just like we did up here, you should plug them into point slope form and convert. So you're going to hear the exact same thing that you heard on the first example right here, and you're going to hear it one more time down here. Once you know the slope and the point, plug them in. So same exact steps. The letter y followed by the point's y coordinate. So the opposite of 3 is -3. Okay? Then comes our equal sign and our slope. Our slope is 1/2 because our slope had to be the same as this one because our lines need to be parallel. Okay, then comes the letter x in parentheses followed by the opposite of the x. So the x coordinate is 2, the opposite is -2. We do the same thing here that we did up here. You plug in the point and the slope, you put bars over your equal sign, and you convert. So you distribute 1/2 into your parentheses. 1/2 times x is 1/2 x. 1/2 times -2, well, half of -2 is -1. So 1/2 x minus 1 equals y minus 3. And then what's always the last step to getting it in slope-intercept form? Get y by itself. So get rid of the -3 with +3. And here's what we're left with. Y equals, bring down your 1/2 x. -1 plus 3 is +2. There's the equation. And if you look back now, again, sometimes the visual can help us help these things click. This makes sense now because if you look, this line has the slope of 1/2, right? Rise 1, run 2 when we drew it in. And if you backtrack this, look where it crosses the y-axis. It crosses the y-axis right there at 2, which makes sense because our equation ended with a 2. So y equals 1/2 x minus 5 and y equals 1/2 x plus 2 are parallel lines. -5 is down here, the +2 one is up here, but they both have a slope of 1/2. Okay? So hopefully that visual aid helped make things just a little bit clearer, okay? If a problem tells you that two lines have to be parallel, you get the slope for free. Because whatever the slope of your line up here is, it's got to be the same slope that you plug in, okay? Conversely, okay, you'll notice this is almost the exact same problem as it was up here. The equation they give you is the same, y equals 1/2 x minus 5. The point that your line passes through is the same. It was 2, 3 up here, it's 2, 3 down here. The only difference now is they want us to do the exact same thing. They want us to write the equation of a line, but this time, instead of being parallel to y equals 1/2 x minus 5, it wants it to be perpendicular, okay? So there was a big chunk of problems on the quiz itself where you had to identify if two lines were perpendicular. The way you'll know that they're perpendicular is their slopes. But their slopes won't be the same. Their slopes will be opposite reciprocals. So if it says perpendicular, you need to change the slope from a positive to a negative, and it's reciprocal. So the reciprocal of 1/2 is 2/1. my line has to have a slope of negative 2 over 1, or if you think about that, that's just negative 2. So the slope that I'm going to plug in just a second here is going to be negative 2. But if we go up here and we think about this, just again, to get the visual aid and use it, if you go through the point 2, 3, that's again this point right here, but you go down 2, right 1, so from here you go down 2, right 1, and then you connect those, you'll notice what you'll get are perpendicular lines. Perpendicular lines are lines that intersect at right angles. Okay? Again, the visual aid, the graph, is just meant to hopefully help make things click a little bit better. The thing you need to remember, though, is on your assignment today and then on the quiz tomorrow, if it says you need to write the equation of a line perpendicular to this, you need to change the slope. You don't just get to use the slope. It's not just 1 over 2. It's the opposite reciprocal. So negative 2 over 1, or just negative 2. From here, though, once you get this, it's the exact same work, you guys. It's the letter y followed by the opposite of the y coordinate. So opposite of 3 is negative 3. Then our slope. So our slope for this problem is negative 2. Then it's the x and the opposite of the x coordinate. So the opposite of positive 2 is negative 2. And then it's always the same steps. Distribute your negative 2. You get negative 2x. Negative 2 times negative 2 is positive 4. Bring down the y minus 3. And then add 3 to get rid of it again. Add 3, add 3. We get y equals negative 2x plus 7. There's an equation in slope-intercept form where the slopes are opposite reciprocals. Their y-intercepts don't impact anything. It's just the slopes that matter, okay? Now, sort of the last thing that I want to mention is just kind of to reiterate here. As I went through the people's quizzes that took their quizzes, I saw kind of a variety of mistakes. I have not addressed all those individual mistakes here. Instead, what I have done is reiterated the correct way of doing this. So if you know that you did some stuff completely different on the quiz than we have here, you know that you did it somehow incorrectly, okay? Just remember, to kind of a final recap here, if you have not taken your quiz yet because you missed it last week, you'll be taking the quiz in class tomorrow, okay? If you took your quiz already, I sent you an email yesterday that told you to check Skyward so you could see what your overall grade is, what your quiz grade is, and then you have to make the decision if you're going to take the retake. You should all either have already emailed me or you should email me today with what your decision is. If you took the quiz, you need to email me, yes, I want to do the retake, or no, I don't want to do the retake. But if you choose not to, then obviously your quiz grade does not change, and neither does your overall grade, okay? So hopefully all this makes sense. Hopefully, the last 3 days have really helped to clear things up for you if you were somebody who struggled with the quiz the first go around. Hopefully things are significantly more clear. Keep the questions coming if you do have them. Otherwise, just finish up this last review assignment, and then tomorrow, if you're taking the quiz, you'll take the quiz. If you're not, then you'll basically just need to sit quietly, either working on other homework on your computer, reading a book, whatever the case may be. But I need to make sure that at the end of the day tomorrow, everybody has taken their quiz, whether you're, again, in school or you're working remotely from home while you're on quarantine. Then I need to make sure that you guys get logged on to our Zoom meeting or our Google meeting so that you can take your quiz from home while I kind of can keep an eye on you, okay? All right, guys, that'll do it for today. Just make sure you're ready to go on the quiz or the retake quiz if you're in that category. Have a great day, you guys. I'll talk to you later.